Hello students, today's first question is, when the natural numbers 1, 2, 3, so on up to 500 are written. So we have to write natural numbers from 1, 2, 3, so on up to 500. Now, then the digit 3 is used n times in this way. So digit 3 is used, the value of n is, so how the digit 3 is used how many times. So we need to find how many times digit 3 is used between 1 to 3 up to 500. Now, in any sequence, we know that number 3 is used at unit digit. Let us suppose from 1 to 100. So, just like from 1 to 10, it is used 3, then 13, then 23, 33, 43, 53, 63, 73, 83 and 93. So this is when at unit digit there is 3. So how many times it is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Now this is from 1 to 100. So 10 times from 1 to 100. So up to 500 it would be 10 into 5 times. So 50 times it is used at unit digit. Right? Now at tens digit. So at tens digit it is used when I write 30, then 31, 32, 33, 34, 35, 36, 37, 38 and 39. Right? So it is used at tens digit 3. Right? So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times between 1 to 100. So up to 500 it will be 10 into 5, 50. Right? Now at 100 digit, so at 100 digit, the unit 3 is used when we count from 301, 302, so on up to 399. So at 100 digit it will be used how many times? 100 times. Right? So this will be 100. And this is only happening between 1 to 100 for the series 300 to 399. So I will have to multiply by 1, so that will be 100 only. Now combining this 50 plus 50 plus 100 will be equal to 100 to 100. So basically the digit 3 occurs between 1 and 500. How many times? 200 times. So right option for this question will be option number B, 200 times. Right? In how many ways can 11466600, so 11466600 be written as the product of two factors? So whenever such kind of question comes, first of all what you will do, you will prime factorize it. So I can write this as 11466 multiplied by 100, and I know 100 is 5 square into 2 square, 25 into 4 is 100. So basically I need to prime factorize 11466. So I will prime factorize separately 11466. Now, since it is an even number, first I will try with 2. So this will be 5, then 7, then 3 and 3. Then again 7, 5, 12. Now it will be 3 since it is not an even number anymore. So 3, 1, 27, 9, 1, 1. So 9, 10, again it is divisible by 3. So 3, 6, 18. 1 remainder, so 11, 3, 2, 9, 21, 7. Now 6, 8, 8, 7, 15. So again I will divide it by 3. So 2, 0 and 9. Now it is not divisible by 3 further. Sorry, this is 637 over here. 3, 6, 18, 11, 3, 3, 9 and then 21. Now 6, 3, 9, 7, 16. So it is not divisible by 3. Now with 7, 9 is 63. So this is 63. 637. 7, 9 is 63 and then 91. Again if I try it by 7, so it will be 7 into 13. So the prime factorization is giving me 1, 2 from here, it is 2 square, so that will be 2 cube multiplied by 3 square, then 5 square, then 7 square into, not 11, 13. So that is prime factorization. After prime factorization I get 2 cube, 3 square, 5 square, 7 square and 13. So now we know that when we need to find total number of factors, so total number of factors of this number will be when I add the powers and add 1 to each power. So that will be 3 plus 1 4 multiplied by 2 plus 1 3, 3, 3 and 2. So this is basically 4, 3, 12, 12, 3, 36, 36 into 6. So that is equal to basically 6 cube, and that is 216. So total number of factors of this number is 216. Now what we have been asked? We have been asked in how many ways can this number be written as product of two factors. So you know that for writing the product of two factors we need two numbers. So that means any pair or pairing of two numbers from this total number of factors. That means total number of products that it can be represented is 216 divided by 2, which is equal to 108. So in 108 ways it can be represented as product of two factors. So right option for this question will be option number B, 108, right? So simply whenever you are being asked to find a product of two factors, a number, just prime factorize it, find the total number of factors and divide it by 2, because let us suppose it is having, suppose we are having 12, right? Now the number of factors is 1, this side 12, then 2, 6, 3 and 4. So total number of factors is, now if a prime factorize it, it becomes 4 into 3, that is 2 square into 3. So total number of factors will be 3 into 2 equal to 6, and I have written all the factors, right? Now the question asks in how many ways it can be represented as product of two factors. So total number of factors are 6, so it can be represented in a way 6 divided by 2 equal to 3. In 3 ways it can be represented. How? It is 1 into 12. First is 1 into 12. Now 2 factors have been consumed in this. Now next is 2 into 6, and last will be 3 into 4. So that means in order to represent any number in product of two factors, we have to divide total number of factors by 2. So same what we have done over here. So the right option for this question will be option number B, 108. How many natural numbers up to 990 are divisible by 5 and 9 both, but not by 7? So up to 990 means less than or equal to 990 must be divisible by 5 and 9, but not by 7. So the numbers up to 990 from, so let us suppose x is greater than equal to 1 and less than equal to 990. Now the numbers which are divisible by 599, so that means it must be divisible by 9 into 5, 45, right? Now numbers will be, first number will be 45, then 90, then 135, so on. Now we have to check the largest number up to 990 which is divisible by 45. So first of all we will divide 990 by 45. So that is 45, 2s and 90, then 90 again, so 22. So that means the multiple of 45 up to 22 which is equal to 990. So that means there are 22 numbers which are divisible by both 5 and 9, right? Now the number should not be divisible by 7. Now what will be the form of the numbers which will be divisible by 7? So that will be 45 into 7 into some number n1, right? Now the very first number will be 45 into 7, right? That means this is basically, if I write this is 90 and then 135, so on up to, so I can write it in the form 45 into 1, 45 into 2, 45 into 3, so on up to 45 into 22. Now you see the numbers of the form 45 into 7 into n, where n1 is some natural number. So first will be 45 into 7, next will be 45 into 7 into 2. So this is basically 45 into 14, and the third will be 45 into 21. Now I can't write 4th, because if I write 4th 45 into 28, that is not included in this list because it is up to 45 into 22. So I will discard this. So there are only 3 numbers, 45 into 7, 45 into 14 and 45 into 21, which are divisible by 7 in this list. So I will subtract these 3 numbers, giving us the number which are divisible only by 5 and 9 but not divisible by 7. So the right option for this particular question will be option number B, 19. The number of solutions of mod of x plus mod of y less than equal to 0 for x, y belongs to real numbers. So number of solutions for mod of x plus mod of y less than equal to 0, where it has been given that x and y, so this symbol basically represents, and you must remember this, belongs to, right? So that is belongs to, R means real numbers, right? Now any mod of anything will always result into a positive number. Let us suppose mod of minus 2 is equal to 2. mod of minus 5 will result into 5, and mod of positive number will always result in, let us suppose 2, so that will result in 2. Now we have been given that mod of x plus mod of y is less than or equal to 0. Now in any case, can this be possible that mod of x plus mod of y is less than 0? Can this be possible? No, because mod will always give a positive value. So the only option left is mod of x plus mod of y equal to 0, and that can happen only when, since x and y belongs to real number, so x and y should be having value 0, 0. Now we have been asked to find number of solutions. The only solution for this is when x and y are having value 0 and 0. So the only solution, number of solutions will be only 1, and the right option will be option number B. Right? Most of the students tick infinitely many. No, infinitely many is not the solution, because I have told you that mod of x plus mod of y can it be less than 0? No, it can't be less than 0. The remainder, when 2 raised to power 39 is divided by 39 is, so when 2 raised to power 39 is divided by 39, we need to find what is the remainder. Now 2 raised to power 39 can be written as 2 raised to power 6 whole raised to power 6. So this is 2 raised to power 36. So separately I have to write 2 raised to power 3 divided by 39. Now 2 raised to power 36 is basically 64. So I will write 64. I can write 64 raised to power 6 dot 2 raised to power 3 equal to 39. Now this 2 raised to power 36 plus and 2 raised to power cube, again if I add, it gives me 2 raised to power 39. Now when 64 individually is divided by 39, so it is 64 divided by 39. So that is 39 ones, so that is 39, and the remainder is 50, 14, 9, and that is 5, and here 5, 3, 25. So when I divide this by this, so I will be getting remainder 25. So I can write 25 raised to power 6, because I would be getting remainder 25 6 times, so 25 raised to power 6. If you want, I have made a separate video, detailed video on the remainders concept. So this is 8 divided by 39. Fine. Now 25 raised to power 6 can be written as 5 raised to power 3. So this is basically 5 square whole raised to power 6 dot 8 into 39. Right? Or I can write this as 5 square multiplied by 2 into 3 dot 8 divided by 39. Now my purpose is, because 39 multiplied by 5 is 9 5 45, and 5 3 15, and this is 19. Now 39 into 3, that will be 9 3 27, 3 3 9, and this is 11, 117. But when I divide 39 by 16, so I get 9 6 54, 5 6 3 18, 23, then 9 3, so 4, 9 3 12, and 3 2 5 6, so 624. Now I know that 5 raised to power 4 or 25 square is 625, right? So I will write in the form this 5 square whole square. So this is 25. 25 square is 625. So I can write 625 whole cube into 8 divided by 39. Now 39 into 16 is 624. So when this gets divided, I would be getting remainder 1 cube into 8 divided by 39. So basically when I divide 8 by 39, I would be getting remainder as 8. So this whole process was to get 39 as close as to the numerator, so as to we have a remainder of 1 or 2. So the remainder for this case is 8. So right option will be option number C. The unit digit of the following expression. So the expression is 1 factorial whole raised to power 99 plus 2 factorial whole raised to power 98 plus 3 factorial whole raised to power 97 plus 4 factorial whole raised to power 96 plus so on plus 99 factorial whole raised to power 1. So basically what is happening, that the power for the first number started from 99 and it is getting decreased as we reach to 99, the power becomes of the 1. Now for this we need two concepts. First is cyclicity and second is unit digit concept. I have made a separate detailed video on these both topics. You can go and watch those, and a lot of questions regarding cyclicity and unit digit. Now here 1 raised to power 99, 1 factorial is 1 raised to power 99. Now unit digit of this will be obviously 1, right? Now
when it comes to 2 factorial, so 2 factorial is basically 2 into 1 raised to power 99. So basically we are checking for the 2 raised to power 98. Now for 2, if I write 2 raised to power 1, it is 2, 2 raised to power 2 is 4, 2 raised to power 3 is 8, and 2 raised to power 4 is 16. Now if I write 2 raised to power 5, it is 32, 2 raised to power 6, it is 64. So basically what I am trying to tell you is that the cyclicity of 2 is 4 and sequence is 2486, right? So what we need to check that the power is divisible by 4. So 98 divided by 4, it gives me at 96 it is completely divisible, and it is giving me remainder 2. So what does that mean? That means the unit digit will come after repeating how many cycles? So that will be 96 divided by 4, that will be 2, then 16, 24. So 24 cycles will be repeated with the unit digit 2486 multiplied by 24, right? And after that there will be 2 powers, 2 raised to power 97 and 2 raised to power 98. So 2 raised to power 98 will end with unit digit 4. So it will have unit digit 4, right? Now 3 factorial. 3 factorial is basically 3 into 2 into 1 raised to power 97. So this is basically 6 raised to power 97. Now the cyclicity of 6. Now 6 raised to power 1 is 6. 6 raised to power 2, 36. 6 raised to power 3 is 36 into 6, 216. So we know that cyclicity of 6 cyclicity is 1, and sequence is always it will be having unit digit 6. So any power 6 raised to power any power, it will have unit digit as 6. So these all are, we are writing unit digits, right? Now 4 factorial is 4 into 3 into 2 into 1 raised to power 96. So what does that basically is? 43. 4 into 3 is 12, 12 into 2 24. So 24 raised to power 96. Now unit digit over here there is 4. So 4 raised to power 96. Now cyclicity of 4. 4 raised to power 1 is 4. 4 raised to power 2 is 16. 4 raised to power 3 is 64, right? And 4 raised to power 4 is 256. So the cyclicity becomes, cyclicity for 4 is 2, and the sequence is 4 and 6. Now the power is 96, which is completely divisible by 4. So 90 at the power 96, its unit digit will be 6. So I can write over here 6. Now beyond that it will be 5 factorial. So 5 factorial is 5 into 4 into 3 into 2 into 1. Raised to power will be 95. Now this means 20, this is 24 into 5, so that is 120 raised to power 95. Now further beyond this will be 6 factorial. 6 factorial is equal to 6 into 5 factorial, raised to power will be 94. Now 5 factorial is 120, so 120 into 6 will be 720. And you see here every time we are getting 0. So this is because of the fact that you must know that beyond greater than equal to 5 factorial, the unit digit is always equal to 0. You must write this into your notes, that beyond 5 factorial, equal to 5 factorial or greater than that, unit digit will always be equal to 0. And that why it is happening, as we get in 5 factorial 5 into 2 combination, it gives us 10 and unit digit will always be 0. So that means beyond this everything will be having unit digit at there, unit digit as 0. So we have been asked to find the unit digit of this expression, so that will be equal to 1 plus 4 plus 6 plus 6. So that is 6, 6, 12, 12 plus 4, 14, and 12 plus 4, 16, plus 1, 17. So the unit digit will be equal to 7. So the right option for this question will be option number C, 7 with the unit digit of this expression. The sum of all 4-digit numbers which are divisible by 7 is. So how will we approach that? I have told you that such kind of question should always be approached with arithmetic progression. So first 4-digit number is 1000 and the last 4-digit number is 9999. Now between this we need to find sum of those numbers which are divisible by 7. Now from this side we will first calculate. Now 1000 is not divisible by 7. We will try to solve it for 1001. So that is 7 1. So now 34, so 21, so that is 147. So smallest 4-digit number which is divisible by 7 is 1001. Now 999 is not divisible by 7, so 9998. divided by 7. So this is 7, 1, then 29, so 7, 4, then 19, 4, 58, so 56, so it is not divisible, giving us a remainder 2. So that means 9996 will be divisible by 7. So that will be equal to 1, then 29, so 4, 19 will give me 2. So this is 2, then 56, 8. So we have found both the numbers, 4-digit numbers, highest and lowest, which are divisible by 7. Now, to find out how many terms are there, we have a formula that nth term an is equal to first term a plus n minus 1 multiplied by d. For this case, d is 7. Now nth term is 996. What we are trying to find is the number of terms in between. So that is 1001 plus n minus 1 dot 7. So that is 999 minus 996 minus 1001. So this comes out to be 8995 divided by 7 equal to n minus 1. So that is equal to, dividing by 7, 1285. So n minus 1 is equal to 1285, which gives me the value of n equal to 1286. So this basically means there are 1286 numbers between 1001 to 9996 which are divisible by 7. Now we need to find the sum. So sum of n terms is always equal to n by 2. So that is 1286 divided by 2. We have two formulas for that. That is, first is n by 2 bracket 2a plus n minus 1 into d. Or in this case, I can simply write n by 2 first term plus last term, as we know both the terms. So first term is 1001 and last term is 9996. How it came? I can write this as 2a equal to a plus n minus 1 into d. So this is first term and this is the last term. So you can write this formula into this form also for an AP. Now 1286 divided by 2. So that is equal to 643 multiplied by 1001 plus 9996. So that is equal to 10997. So when you multiply it, you get 707171. So this is the sum of 4-digit numbers which are divisible by 7. So right option for this will be option number A, 7071071. So right option will be option A. When the numerator of a positive fraction is increased by 2 and the denominator of the same fraction is multiplied by 2, the new fraction can be reduced to 1 by 2 to its lowest term. The sum of the numerator and denominator of the original fraction can be, so let us suppose the original fraction is x upon y. Now the operation on this is the numerator is increased by 2. So that means numerator is increased by 2 is x plus 2. And the denominator of the same fraction is multiplied by 2. So that means 2y. So this is equal to 1 by 2. Now by cross multiplication I get 2x plus 4 equal to 2y. Or I can write x plus 2 equal to y, taking 2 common. Or I can write y minus x equal to 2. So what does we deduce from here? That y is greater than x, that denominator is greater than numerator. And for second thing, you see that the difference of two numbers is even. So in what cases it can happen? It can happen when odd minus odd is equal to even. Let us suppose an example for this. 5 minus 3 is equal to 2. Or even minus even. So that is 6 minus 4 is equal to 2. So that is also even. So this means that y and x can be both odd or both even, right? Now we have been asked to find what can be the sum of numerator and denominator. So we need to find x plus y. Now even plus even is equal to even, and odd plus odd is also equal to even. So what does we deduce from here is that no matter whether x and y are odd or they are both even, the result will always be an even number. Now in the options, A is odd, B is odd, C 16 is even. So we can have C in our option, and last is any even integer greater than 3. So this is a particular number. So and this is a generalized form that any even integer greater than 3. So now let us suppose some examples for this. Now 5 minus 3. So this is 3 by 5. 3 by 5. So let us suppose this to be the original fraction. Now if we add 2 to the numerator, so that becomes 5, and dividing and multiplying denominator by 2, so that becomes 10. So this becomes 1 by 2. So what has been told in the expression, that after adding 2 to numerator and multiplying 2 by denominator, so the expression reduces to 1 by 2. Now in this case, the original numbers were 5 and 3, and 5 plus 3 is equal to 8. Now let us suppose the smallest even integer, so that will be 2. So 4 minus 2 is equal to 2. So that means y is value 2, x is having 2, y is 4. Now 4 divided by 8 is again 1 by 2. And both the cases, smallest possible numbers, we are having x plus y is equal to 6, and here x plus y is equal to 8. So we can generalize this, that any even integer greater than 3. So 16 is also a solution, but it is a particular solution. But the generalized term, we have a solution any even integer, because we have seen by getting the lowest integers for even as well as odd, we are getting x plus y in this case equal to 8, and here x plus y equal to 6. So we will say option D is the right answer, that it can be any even integer greater than 3. Now the digits of a 3-digit number are in GP. So we have been given that 3 numbers of a 3-digit numbers are in GP. So that is geometric progression. That means the ratio would be same of the digits. Now when the digits of this number are reversed and this resultant number is subtracted from the original number, the difference comes out to be 792. So we have been given 2 conditions. So we need to find the actual number is. Now we will start with first number 842. Now we need to have 2 operations on this. First is GP operation. So that is 4 divided by 2 must be equal to 8 divided by 4. So this is 2 and this is 2. So they are following this condition. Now second condition is when 842 minus, reversing the digit means 248. So 842 minus 248 can never give me the difference equal to 792. So option A is out of question. Now moving to option B. Option B again 961. So GP ratio, that is 6 by 1 should be equal to 9 by 6, but this is not equal, this is 6 and this is 3 by 2. So our B option is cancelled over here. Now moving to, we need not to check the difference even now for statement for option C 421. Now for finding GP, so that is 2 by 1 equal to 4 by 2. So GP ratio is coming equal. Now we'll check it for 421 minus 124. So this can't be equal to 792. So option C is also not correct. So we'll mark the option D. So this kind of approach is called eliminating the wrong ones. Right? Now we will, for the sake of question, we will try for 931. So option D is 931. Now ratio is 3 by 1 equal to 9 by 3. 9 by 3 is also equal to 3 by 1. So GP ratio is equal. Now 931 minus 139. So 139. So this will be 1192. So here 12. So 3, 9 and 8, 1, 792. So difference is also coming out to be 792. So for this particular question, we will mark option D. So having options, sometimes you can have directly by solving the options, you can find the solution. So right option in this question is option D. How many even integers n such that n is greater than equal to 13 and less than equal to 330 are of the form 3k plus 4. So are of the form 3k plus 4 where k is any natural number. So we need to find in between this how many even numbers, even integers are of the form 3k plus 4, right, where k is any natural number. Now first of all, the first even number after this is 14. So we'll try 3k plus 14 plus 4 is equal to 14. So this gives 3k is equal to 10 and k equal to 10 by 3. So this is not the, so n is not equal to 14. So the next value will be 3k plus 4 is equal to 16. So 3k will be equal to 12 and k will be equal to 4. So the first value of k is 4. Now it goes up to 330. So since 313 is an odd integer, the very next below 313, the even integer is 312. So 3k plus 4 is equal to 312. So that means 3k is equal to 308. Now 8 plus 3 is 11, so this is not divisible. So next will be 3k plus 4 equal to 310. So this will be 3k equal to 306. Now this is divisible, so this will be 306 divided by 3. So this will be equal to 102, right? Now the value of k starts from 4 and ends up to 102. So how many even integers will be? So that can be determined. Now 4. Now here we will take one other value. Now if we take 3k plus 4 is equal to 18, so 3k will be equal to 14. So k is not having value 14 by 3. Now next will be 3k plus 4 equal to 20, right? So that will be 3k equal to 16. So k is equal to 16 by 3 is not a value. Now next will be 3k plus 4 equal to 22. So 3k will be equal to 18 and k will be having value 6. So now the sequence for k becomes 4, 6, 8, 10, so on up to 102. Now we need to find how many numbers are there. So that will be equal to the number of values of k. So k can be found out that by a nth is equal to a plus n minus 1 into d. So nth term is 102. Shifting this to this side, so this is equal to 4 plus n minus 1 dot 2. So this is equal to 102 minus 4 is 98 divided by 2 equal to n plus 1. So this implies this is equal to n minus 1 is equal to 49 and n is equal to 50. So this is 50 is basically the values of k lying between 4 to 102 with a common difference of 2, right? So we have been asked how many even integers n are of the form 3k plus 4 where k is any natural number. So this is basically that number, and right option for this question will be option number C, 50. So this question will particularly, I will say, this is the application question for use of AP, arithmetic progression. If P is equal to 101 raised to power 100, so P is basically equal to 101 raised to power 100, and Q is equal to 100 raised to power 101, right? Then the correct relation is P is greater than Q, P is less than Q, P is equal to Q, or P is equal to 11 by 10 of Q. Now since P, here I will write P, here I will write Q. Now P is equal to 101 whole raised to power 100 and Q is 100 raised to power 101, right? Now I can write 100 raised to power 101 as 100 raised to power 100 multiplied by 100, right? Since base is same, powers added, so again it will be 100 raised to power 101, and I will write 101 as it is. Now if I divide both sides by 100 raised to power 100, so this will become divided by 100 and this is 100 raised to power 100, 100 raised to power 100. Now here in the law of exponent, I have made a detailed video on law of exponents and indices. You can go and watch that video, but here the question is a raised to power m upon b raised to power m, right? Now bases are not same but exponents are same, so I can write this as a by p whole raised to power m. So I can write this as 101 upon 100 whole raised to by combining the power, taking the power common. Here 100 and this gets cancelled and I am left with 100. Now this is equal to 1.01 whole raised to power 100 and this is 100. Now I can clearly see that P is less than Q, that 1.101 raised to power 100 will be less than 100. So I can say that for this particular question, option B, P is less than Q is the right answer. If k square minus 25 is an odd integer, so we have been given a condition that k square minus 25 is an odd integer, right? Now then which one of the following values gives the even number? So out of these three, which of these gives us a even number? Now we know that even minus even is equal to even, odd minus odd is equal to odd, odd minus odd is equal to even. So we can have some values for this. So this is 6 minus 2 equal to 4, odd minus odd, 5 minus 3 is equal to 2. Now even minus odd, or we can say plus minus. Here also we can have plus minus plus minus. 6 plus 2 is 8 is also even. 5 plus 3, 8 is also even. So even plus minus odd is equal to odd. We can have example 6 minus 3. So that is equal to 3, or 6 plus 3 is equal to 3, 9. So these are odd. So even plus minus odd is odd. Now this is odd, 25. So what we infer about k square? So we infer about k square is that k square has to be even, right? Now what would be the nature of k if k square is even? Now even multiplied by even is equal to even. Example for this is, since we are talking of squares, so I will write 6 into 6 is 36, or we can have different examples. 6 into 8 is 48. Now odd multiplied by odd, so that is basically 3 multiplied by 5, so that is 15. So since k square is even, I can say that k has to be even, right? So we logically deduce that k must be an even number. Now we need to find which of the following values gives us a even number. Now we need to check for k raised to power 2k minus 1. So let us suppose k to be equal to 2. Now 2 raised to power 2 into 2, 4 minus 1, 3. So this is 8. So this is an even number. So we can say that first is an even number. Now k equal to 2, checking for statement 2. Statement 2 is 3 into 2, 6, 6 minus 3. And 2 into 2, 4 minus 2 is, so this is 3 dot 2, 6. So that means second is also even. So these two gives us an even number. Now third, k plus 5. So that is 2 plus 5, 7 dot 2 minus 5 minus 3. So this is minus 21. So this is an odd number. So we can say surely that first and 2, second gives us a even number. So right option for this will be option number D, exactly 2. So exactly 2, that will state option number D is the right answer. Without putting the values, we can check for these values also. So k is an even number, right? Now even raised to power 2 multiplied by k will also be even, but even minus odd will be odd. So this is even minus odd. So even power raised to power odd power. So that will give me even number. We can have an example for this, that even number 4 raised to power an odd power 3. So what is this? This is 4, 16 into 4, 64. So this will yield us an even number. So statement 1 will yield me an even number, right? Now statement 2 is 3k. So that will be even minus odd, right? So even minus odd will be odd. And here even 2k will be an even number minus even number. So that is even minus even is even. And any odd number multiplied by even number will give me an even number. Now checking for third. So that is k plus 5. So what is that? K is even. So even plus odd is even. Sorry, even plus odd is odd multiplied by even minus odd. So even minus odd is also odd. And we know that odd into odd yields us an odd number. So this will be an odd number. So statement 3 will not yield us an even number. So right option will be exactly 2, and that is option number D. Right? Thank you for today's lecture. If you find any error, please do comment so that I can rectify it. And if you want some video on a special topic, please do comment. If you want your concepts to be solid, please read 8th, 9th, 10th NCERT books, easily available on the NCERT website, chapter wise or the complete book, and you have to read between exercises. That is where the concept lies. It has been meticulously prepared by the eminent professors of our country. Bye bye, take care.